Are live. Okay, good. So here we go. Topic is linear functions. 9, 10, 19. So linear really means straight. Straight line, okay? Not curved at all. So when you see the word linear, think line, think straight line, okay? So before we even start linear function, let's go right back to y equals mx plus b is our standard equation for a linear function. We know that m is the slope and b is the y-intercept, right? So m is the slope. One way to get the slope is our slope formula, which is our y2 minus our y1 over our x2 minus our x1, which is what we've been doing, haven't we? We've been doing the slope formula. All of that was finding the slope, but of a curved line. So the slope of a straight line is constant. It never changes, right? And our b is our y-intercept. That's my y-intercept. There we go. Intercept. Kind of sloppy. My bad. Okay. What does this say? Example 4. Oh, I'm on the wrong side. It's okay. Let's pass over the. We'll do the story problem bit. Okay. I'm on the wrong side. No problem. Linear functions. Right? Y equals mx plus b. 9, 10, 19. Okay. Example 1. So the equation of a line with slope 2/3 passing through the point -3, 12. That's easy, right? So if we use our y equals mx plus b, right? This is all the way back to Algebra 1, so this is going to be a real quick review. If you don't know what I'm doing, then I'm very sorry for you. You should. How's that for an answer, okay? So I know my slope is 2/3, right? I need to find b, so I have an x and a y value. Every point has an x and y value, right? So I'll plug my 12 in for y. I'll plug my -3 in for x, and we'll solve for b. Solve for b, okay? Two ways to do this multiplication, and I know that most kids can't do fractions. One is 2 times -3 is -6, divided by 3 is -2. Or, for me personally, it's just simpler to cancel the 3's. You okay, cancel the 3's, right? And then I get a 12 equals a -2 plus b. That's simpler for me. I just cross reduce.
Why is it?
Yeah, why is it -2?
Negative times the 2. Or what's this over this is -1?
Yeah.
This is, so -1 times 2 is -2. Or again, it's fine to do it the other way. Right? If you go 2 times -3 is -6 divided by 3 is -2. You okay with that? That's easier, okay? And then I'm just going to go plus 2, and I'm going to get b as 12, as 14. So then my answer is y equals my 2/3 x plus 14. Now, I'm going to do one slight change. I'm going to write it as a function. It is a function, right? So let's write it as f of x equals 2/3 x plus 14, okay? That's a 14. Now, I'm going to tell you something that I hopefully already know. Whatever this variable is, it has to go there because it's the function of that variable. Okay? Whatever variable's here, it has to go because it's the function of that variable. Does that make sense? Always. Always, always, always. It's the function of x. Okay, that was easy. Okay. Number 2, find the equation of line through these points. So, first we're going to have to find slope. So first, let's find our slope. I'm going to use my y2 minus my y1 over my x2 minus my x1, right? Every point has an x and a y. x1, y1, x2, y2, right? First point, x1, y1. Second point, x2, y2. It's that simple. It's that simple. And we like the second point to oftentimes be the x2, y2 because those are the bigger numbers sometimes. Anyway, plug them in. So I'm going to go, and my slope is going to be my 1 minus 5 over my -2 minus 3, which is going to be -4 over -6, or 2/3.
How am I doing?
How'd you get 6?
No.
-5?
Yes. Thank you. How about 4/5? I didn't. How's that for an answer, Kaiwa? Thank you. How about positive 4/5? Thank you. So now, I'm going to teach you a new equation, which you may or may not remember, but I'm going to teach you what we call the point slope formula, okay? So I'm going to teach you the point slope formula, okay? It is, and I like this one, it is y minus y1 equals m times x minus x1, okay? Anybody remember that? Good. Good. You guys remember that? Now, you could go back and use the y equals mx plus b. This is just another version of it. I like this, and you're going to see why I like this, okay? So, to use this formula, I'm going to go y minus 5, because I'm going to put my 5 right there. Put my 5 there, because that's y1, right? Equals 4/5 times x minus 3. I'm going to put my 3 right there, because that's my x1. Yep. Thank you. Yeah, you can't see what I'm doing. There we go. Now you can. So, here's my formula. y1 is 5, and x1 is my 3, and I know what my slope is, 4/5. Okay, and now all we have to do is just simplify our answers there. That's why I like this one. There's no rewriting. You just do it and you get the answer. Okay, so then if I simplify this, I've got a y minus 5 equals a 4/5 x minus 12/5.
Minus 12/5?
Yeah. 4 times 3. 3 over 1. Okay, so I get 4 times 3. 5 times 1. Okay. 12/5, same thing as 2 and 2/5, right? So I got a y minus 5 equals 4/5 minus 2 and 2/5, right? I just changed 12/5 into 2 and 2/5. It just makes it easy for me. So now if I go plus 5, I'll get a 2 and 3/5, right? So my answer would be, and I'm running out of room, but I'll have a y equals 4/5 x plus 2 and 3/5. Okay, and if you don't like fractions, if you hate fractions, okay, yeah.
Because he added 5.
5 minus 2.4 is 2.6, yeah, right? And again, I was just going to show that if you hate fractions, if you're a fraction hater, just do decimals, right? Right? If you're a fraction hater, just do decimals. See, I can do decimals. And the answers can be just fine. You want me to show it with decimals?
Yeah.
Okay, so if I show it with decimals, let me come on over to the board, do it with decimals. So, okay, fraction haters, here we go. We'll just do this whole thing again. We go y minus, what was it, 5 equals, now 4/5, same thing as 0.8. 4/5 is 0.8, right? Times my x minus, what was it, 3? X minus 3, okay.
Yeah.
And then just use y minus 5 equals 0.8x minus, what is that, 2.4, right? So if you are a fraction hater, just use decimals. Plus 5, you calculate y equals 0.8x plus 2.6. How's that? Same answer, decimals versus fractions, okay? Because there are fraction haters out there right there. Oh, I don't mind fractions. They don't scare me. Okay. All right. Number 3. I need a piece of graph paper. Okay. I'm going to get a piece of graph paper. If you need graph paper, it is right here. So let's take a look at number 3. Okay. Dam is built on a river to create a reservoir. The water level is 4. Okay. Am I going too fast?
No, I
You get the? Are you okay on the decimal? You sure you're okay?
Yep.
Okay. All right. All right, number 3. So, think about the problem. So, what in the world? What is it? It's about a dam, right? It's about the amount of water in a dam. So, the 28 would represent the starting height in feet of water. And the 4.5 means 4.5 feet probably every hour. I don't know if it says time, but I assume every hour. Or every day. What do you guys want? Every day?
Every day.
Every day. So T is in terms of days. That makes more sense, doesn't it? Yeah. So if I did a sketch, I'm going to go ahead and put my... Time is my x-axis, right? It's my time. And Sydney says in terms of days, I agree with that. Let's go days. So I got 1, 2, 3, 4, 5, 7, okay. And then I'm probably going to go by 5s here. I'll probably go squishy. Okay, squishy? All right, I like squishy. Squishy, and I'll probably start with 25, 30, 35, 40, 45, 50. Okay, all right. So sketch the graph. I'm going to show you a super easy way to do the graph, okay? Super easy, okay? 2 points. All I need is 2 points. You guys agree with that? 2 points. Well, 1 point's going to be a 28. Everybody agree? Boom. The second point I'm going to do is, let's plug in 8, 9, 10. If I plug in 10, just for the heck of it, 4.5 times 10 plus 28, what do you get for an answer? 45 plus 28. Okay, what's 45 plus 28? 45 plus 28. I get 73. So 2 points, right? So at 10, I'll go to 73. 60, 73. And that's a lot.
Move it down a bit.
Yeah. Yeah, and that's a lot easier.
No,
The graph.
The graph.
Okay, so now that for me is easier than going, you ready? Up 4.5 over 1, up 4.5 over 1. You it's going to get messy, and I'm probably going to get off. But if I have a point at 0 and a point of 10, and it's straight, it's linear, right? It doesn't curve, just connect the dots. Does that make sense? Isn't that a handy way to graph?
Sure.
And it's more accurate, isn't it? Right? It's much more accurate. Okay, there we go. What's the slope? Okay, what's the slope, you guys? Slope. And what does that represent? What does that represent? What does that represent?
The angle
Okay, days.
and the water level.
Right, so put that all together and tell me what slope represents.
The change of water is over.
Right, change of water height over a day, or I'm just going to say that we have got 4.5 feet of water per day. How's that for words? Would you agree with that? We're gaining 4.5 feet per day. Okay, that's easy. What's the rate of change of the water over time? Same answer, because the rate, get this in your head, rate, slope. Slope, rate. Rate, slope, rate. Rate and slope. So when you're talking about slope, you're talking about the rate, how something moves, right? Okay, cool. Now let's flip the page back to number 4, okay? All right. How am I doing?
Really good.
Good. Okay. Water is being pumped into a swimming pool at a rate of 5 gallons per minute. Initially, the water level is 200 gallons. Okay, so what do you think? Give me an equation.
Y equals 5x plus 200.
Awesome. Awesome. You guys agree with that? Okay, so do you mind if I change the variables? Okay. So water level, that'd be gallons in a sense, right? Per gallon. So I'm going to go, how about if I go G of T equals 5T plus 200. I don't expect you to change the variables, okay? But I like to, because the problem doesn't have to do with X and Y. It has to do with gallons of water over time, right? Okay. B, if the pool has 600 gallons, how many minutes have transpired? Well, what do you do?
Plug 600 in for what?
For what? 600 gallons. We plug 600 into what?
To what?
To which is G, right? Yeah, exactly. So that's easy. 600 equals 5T plus 200. We'll just solve, right? minus 200, minus 200, 400 equals 5t. Divide should be 8, right? 80?
You skipped a lot of steps that I don't know.
Okay, minus 200, minus 200. Divide by 5. And what's that, 80, I think?
Yeah.
And that'd be 80 hours, okay? Easy?
But it says how many minutes.
Can we change it to hours?
Oh, it is per minute. You know,
4,800.
nope. I'm bad. It talks about 5 gallons per minute, so it is minutes. It's not hours. I need to cross off hours. Minutes. That's what happens when I don't have my coffee in the morning.
Thank you for paying.
Example 5. Easy. Mary and John are traveling westward at constant speeds. The graph shows their distance and time. Okay, now think about this. If you look at this whole thing, can anybody tell me what this means right here? What do the y-intercepts represent?
Where are they?
Evan.
How far along on their travel they already are.
So, this is Landon in Leavenworth. And Zoe, you're in Seattle.
Cashmere.
No, you're much further than Cashmere. You're
Vegas.
150 miles, like maybe Washtuckna.
I don't know.
What's
I
that?
don't know, wherever. Like
Bellingham?
Let's go Bellingham,
Yeah.
okay? So Landon's in Leavenworth, Zoe's in Bellingham, right? And you guys take off for Canada, okay? That's it.
Wait.
So who's going faster?
Me.
Oh no.
Mary. Landon.
Thank you.
You're welcome.
All right, I'll get back to you tomorrow.
Oh.
Okay. Okay, so who's going faster? Mary's going faster. Why do you know Mary's going faster? Slope's steeper, right? So Mary's going faster, okay? All right. So A, at what speeds are John and Mary traveling? Okay, so John, let's figure out what John is. Let's figure out John's speed. So John's speed, it's like a slope, right? It's a rate. So John is going from 150. 2 hours later, he's at 250, right? So John's going my 250 minus my, so I'm getting these points here, okay? Minus 150, and he does that in 2 hours, okay?
Can you zoom in?
Yeah. Well, I can't because I'm recording. But
Wait, yeah, you can.
no, it won't zoom out recording. It freezes out. So here's John. At 2 hours, John's at 250 miles. He started at 150, but he did that in 2 hours, right? So his slope is going to be what? 100 over 2, which is 50, okay? So John's rate is going to be 50 miles per hour, okay? So if I do Mary,
It's running at 50 miles per hour.
No,
Driving.
that's a car.
Okay.
driving. So Mary, let's see if we can find a point here and a point here. Mary's going to go 150, right, in 2 hours. You see that? Mary's gone from, in 2 hours she's gone 150 miles, and she's done that in 2 hours, so she's going 75 miles an hour, okay? Find a function for both rates. That's easy, okay? So we'll do John. It's going to be y equals 50x plus 150. Right? And Mary, what's Mary going to be? Tell me what's Mary? 75x plus 0, but that's silly, right? Okay, good. How far will John and Mary travel in 5 hours? How do I do that? Plug it in, right? So John will go y equals 50 times 5 plus 150. What's that? 150 plus 50, 300 probably. 450? Let's see, 50 times 150 plus 150. Oh, mine's way up. What did you say, 400?
Yeah.
I'm going to believe you because my calculator hit the wrong button. 400 miles. And y equals 75 times 5. What'd you get?
375.
375 miles, right? When does Mary pass John? When does Mary pass John?
Like 5.5 hours.
So, how would you do it mathematically? Set them equal. Because when they pass each other, that they're at equal distance. Does that make sense? So you set them equal. So I'm going to go my 50x plus 150 equals my 75x. And I'll solve, right? So when they pass each other is when their distances are equal, so set them equal. Okay. Minus 50x minus 50x. I got 150 equals 25x. Divide by 25. Divide by 25. What is that? 6?
Yeah.
6 hours. Okay. How's that? All right. Stop the recording.